All right, welcome everybody. It is my great delight to introduce Craig Zilles. He's an associate professor from UIUC, University of Illinois Urbana-Champaign. He is going to talk to us about the system, the ecosystem he's built called the computer-based testing facility. Craig has won a number of awards. He's won the IEEE Early Career Teaching Award. He's won quite a few. He's won an NSF Career Award as well as a lot of awards within UIUC. Craig is an outstanding instructor. I've known him for many years through the SIGSE, Special Interest Group of Computer Science Education group, the association, and he's an outstanding speaker. We're just delighted to have him here to talk about CBTF. Folks, let's welcome Craig. Woo! Thank you so much. So again, as I said, ask all the questions you have. I'm going to say some somewhat, very different things to how people do things, and so you're going to have questions, and as I mentioned, ask questions for the people that can't actually be here so that they have their answers when they watch these videos later. So again, I'm going to talk about the computer-based testing facility. The outline of my talk roughly goes like this. I'm going to motivate it, then I'm going to give you an overview of the big picture of the CBTF. I'm going to talk about operational details. I'm going to go relatively quickly through security, testing accommodations. I'll linger a little on cost. If there's specific things you want to know about, ask me there. I'm going to talk about what our exams look like. We've made our own LMS called PeriLearn that gives us the functionality that we wanted in order to do these exams. I'm going to talk about the fact that our exams are asynchronous. Students are taking exams at different times and how they behave and how we employ randomness in order to maintain security. And then I'm going to give you some quasi-experimental results that we've done, studies in classes that show improved learning outcomes by increasing testing frequency. So that's a rough guideline of where we're going. The motivation is we are a big school. So according to the number of bachelor's degrees that we graduate in engineering, we're second largest in the country, second only to Georgia Tech. In order to graduate roughly 2,000 engineers per year, you need to run about 1,000 students per semester through calculus-based physics. Our data structures class runs at about 800 students. We have 3 different CS1s for majors, engineers, and non-majors that all run at about 600 to 800 students per semester. The sequence that we do for all of the other engineers, the statics, dynamics, solid mechanics, runs somewhere between 300 to 500 students per semester in those classes. So we have some big classes. Lots of things scale pretty well. Lectures scale pretty well. Discussion sections scale pretty well. Homework, we can scale pretty well. The big thing that wasn't scaling very well was assessment. So in terms of exam, most of these really large classes are lower level classes where exams are the primary form of summative assessment that people use. So when you have to run an exam in a class of 800 students, what do you have to do? You have to write new exams. You have to print all those exams. You have to proctor. Typically, we run evening exams historically over many rooms. Big nightmare. Ultimately, when you run evening exams, some students have conflicts, so you need to run conflicts. You figure out which students need conflicts, schedule them. Do you write a separate exam for the conflict exam? That's a question. Students get sick. You have testing accommodations. Students need extra time. They need a distract and reduce environment. And then you have to grade all that stuff. And if you have a large class, you have multiple TAs grading the same questions, so you have to worry about inconsistency in your grading. And it's really slow to get that stuff back. Usually it takes about a week to grade all that stuff and get it back to the students. Or people heavily rely on multiple choice, which in a lot of contexts is a concession that we make for efficiency. So this process is sufficiently painful that most faculty don't do it very often, and that's not actually good for the students. There's a lot of research, both theoretical and clinical and practical, that show that more frequent testing is good for learning and long-term retention. So we wanted to set an assessment strategy that scaled to our size and didn't sacrifice quality, because not only were we a big school, but we're also a good school, like you guys are. So we didn't want to dumb down our exams just for the sake of making them efficient. So what we did is we built this thing called the computer-based testing facility, and it consists of 2 main parts. The first part is sophisticated computerized problems. We wanted to be able to test a wide range of learning objectives in an authentic manner. So we built sophisticated computerized problems. This is just an example. I'm going to show you a bunch of examples. One of the key things about them, they're auto-graded in general. A lot of the stuff that we do in STEM classes can be graded objectively, as in there's, we can write a program that tests, did they do this correctly? That stuff fits very well in the computer-based testing facility. The key thing that we do, though, is instead of writing individual problems, we write problem generators. So these are problems that have a piece of code associated with them that either parameterizes them somehow or configures them somehow so that it can generate a wide range of instances of those problems. And so what this means for me is I write the problem once in a very general form, and then I never write that problem again. I just can reuse it semester after semester. I use it for homework. I use it for practice exams. I use it for exams. The second thing we want to do is we want to have a lot of flexibility in the kinds of questions that we ask. Numeric questions, symbolic questions, code writing questions. In order to get that flexibility, the LMSs that we looked at on the market didn't have that flexibility. And so my colleague in mechanical engineering wrote this thing called PrairieLearn. This is open source. And it basically gives us that flexibility. It allows us to write an arbitrary piece of Python or JavaScript code in order to generate the question that we want. So we've written coding questions. I'll talk about those. Questions where you label free body diagrams, questions that take symbolic answers. This is a question that asks you to provide in a matrix. I'll show you some more examples of this. So piece one is being able to express the kinds of things that we want to evaluate through a computer. Piece two is a physical space. So we took over a cluster and made it into our computer-based testing facility. So this is the main room that we're running now. It has a 85-seat capacity. It actually has 90 machines in it, so that if some break, we can, we don't have to send students away. It is proctored, so we have humans that make sure that when students show up, they are who they say they are. We swipe them in. You notice the machines have numbers. We randomly assign the students to machines. So if you and I come in and take the exam at the same time, we're going to get put in different parts of the room. We have privacy screens so that if you sort of lean over and look at the person next to you, they can't see stuff. We provide calculators and scratch paper to students to prevent them from bringing anything in. Basically, you can bring in a writing implement to maintain security. We don't want them taking stuff in or out through the memory in their calculator. We control this computer. We control all the networking on the machine. Basically, we turn everything off and only whitelist specific services. Our LMS, the license servers for MATLAB and stuff like that. But otherwise, they have access to all the software on the machine, which is good because you can use the compilers in writing a CS exam. You can use MATLAB for solving engineering questions. And we have security cameras so that when the proctor sees something funny went on, we can go back and review the video, and we write the most bulletproof academic integrity violation reports that I've ever seen, because you have still images of the student pulling stuff out of their pocket and doing stuff. It's just like, tell me you didn't have your phone out when I have a picture of you having your phone out. We currently run 7 days a week, 12 hours a day. We're 10 a.m. to 10 p.m. Believe it or not, we have students taking exams 9 p.m. on a Friday night. We have students taking exams on the weekend. It's because they're busy during the week. That's when they want to take their exams. We've been doing this for over 4 years now. We started with my class in fall 14, and we've basically been adding 2 to 4 classes per semester by word of mouth. And we have a lot, you can see a lot in computer science, but actually broad coverage across the College of Engineering, which is who's funding this. And we also have classes from statistics and chemistry running now, so we're reaching beyond our College of Engineering. Our growth in number of students, or number of exams that we run per semester, has also been growing roughly linear. The past 3 semesters, we've run on the order of 50,000 exams per semester, so we're running at scale. This semester, we have 7,000 unique students that are taking exams. We've basically been doing this long enough that we kind of feel like we know how to do this. And so that's why now I'm reaching out to other places and saying, hey, you should think about doing this. Let us share our experience with you. So what has this done? It's changed the way that we test. So historically, people would give maybe 2 midterms and a final. Now when they go to the CBTF, they have a schedule that looks more like this, that And maybe every 2 weeks there's a new smaller exam. So these are often 50-minute exams. And in the off weeks, we run what we call second chance exams. So typically what this means is you go in, you take this exam, because it's done on a computer, it's being graded interactively. By the time you leave the CBTF, you know exactly what you got on the exam and which questions you got wrong and what the correct answers would have been. So you know how you did and you know what you did wrong. If the class offers a second chance exam, what that means is you can immediately go away and study the things that you didn't understand. So that you can come back the following week and show us that in fact you are capable of learning this. You may have just misunderstood what was expected of you. And so we typically do this for some kind of score replacement. Different classes do it different ways. But this is something that before the CBTF, I was the only one on campus that I know of that was doing it. And now we have a bunch of classes that are doing it just because once you have the content, the cost of running exams is basically free, which is not how it used to be. And so there's a, it's no longer this incentive for running frequent tests and running tests multiple times.
Can I ask you just a question now, which is when you give them the feedback, is it only on the screen, or do they get to take it away with them at all?
So right now it's only on the screen in almost all the classes. So typically, it's on the screen, and then if you want to look at it again, you go to office hours, and the TA can pull it up and look at it with you there.
Okay. Okay. Is there any reason that you would not allow them? So if the TA can pull it up, if you wrote the code in such a way that the student could pull it up later, would that break your whole model because the student would then have the question? Even though it's randomized, you know what I'm saying?
It depends. So in my class, there's two things. So it used to be, for the coding questions, we didn't grade them interactively. We do that now. It used to be that we would just stick their answers in the database, and then when the exam period is over, we'd dump that and grade them like we auto-graded homework historically. And when we did that, we would take the problem statement and their code and give it to them through SVN. So they had all those what were hidden coding problems that they went out into the world. There's so I used to do that. I don't do that anymore, and I don't do it anymore largely because there's no student demand for it. There's definitely some faculty who have some hidden problems where they don't want them getting out to students even if they're randomizing the numbers. A lot of the problems that I use on my exam, the non-coding questions, these short answer questions, I give them on homework, I give them on the practice exams, and I give them on exams. So there's no information that I'm hiding from those questions. It's just that, again, there's not demand from the students for this information outside of class. But I don't think there's anything like, we definitely could do that if we wanted to, just nobody's had to.
Thank you.
Yep. Other questions? So by all means, jump in.
So two very short questions. One, have you thought about a final replacement? Is there a pedagogic reason why you're not allowing them to kind of say, I messed up on the final, but let me give another shot on that?
So typically we run the finals during finals week,
There's no time.
and there's just no time after that.
And so question two is, could you have a kind of a hybrid model where we use GradeScope, which is really easy to very quickly grade in parallel online. So could you have a model where not all of it is auto-graded? So you could have a really rich question, which we haven't yet written an autograder for, but in that intermittent week between E1 and E1R, we spend some time on a Saturday, it's very short, so we just quickly burst that out with my TAs and actually hand grade that, and then it would show up. They wouldn't see the results.
Yes, no, that would be totally reasonable. So what we do is that in my class, the second chance is only for the coding questions, and so the strategy we use is you take it on the first chance. If you get it working, great. You got 100, boom, you're done. If you didn't get it working, typically you get a pretty low score, and so you're encouraged to come back and take it on the second chance. On the second chance, my class, you have to get, the highest score you can get on that question is 90%. So you're encouraged to get it right the first time. My experience from when we were doing this in pencil and paper was some students would not study for the first chance, go in, see how it was, and if they didn't do well, then they would take all of the questions on the second chance. And when we were hand grading, that was enough of a load that we're like, okay, we need some mechanism to discourage this. And so that's the sort of capping it 90%. I still feel like having, that there's some faculty that have played with this. I think it's important to have some incentive to do well on the first try. Otherwise, students procrastinate and say, well, I'll just do well on the second try. I won't even take the first chance. So what we do is then we auto-grade the second chance, and if you do well, great, you get a good score. But if you don't get a good score, then we have humans go in and hand grade it for partial credit, because sometimes there's value in the code that it's hard to evaluate automatically. But we've had 2 passes of filtering on that so that the number of things that we have humans look at is much smaller than if we had to grade everything that everybody does. Yep.
I was just wondering if you had any more thoughts about right-sizing the hardware lab itself, and have you ever had to scale bigger than that, or is really the factor the room container itself and the cameras and things like that?
So we started in a 40-person room. Initially, it was just my class. We were only running it 8 hours a week, so you can prototype starting small. At some point, as we added classes, we outgrew that room, so we got our current 90-seat room. We have now outgrown that room because of continued growth, and we re-added another 40-person lab back in. I think it basically just is the capacity that you need. We find that students don't want to take exams any earlier than 10 a.m., and we don't think it's good for students to take exams after 10 p.m. We definitely have students that would sign up for 3 a.m. slots if we offered them, but I don't think that's the right time for summative assessment. That even if they think they want that, I don't think they actually want that. And also, we would then have to staff it with proctors, which gets more challenging. So we tend to run at about 70% capacity, that we have, 1 over 7.7 times as many seats for the number of exams that need to be taken during that period. And so we just basically scale the lab based on expected demand. Yep.
Can you talk more about you're saying you have a generative question maker, and you were saying
I'll show you some examples and we can talk about that. So let me catch that. Other things, awesome. Okay, so go ahead.
You gave a list of subjects. I noticed math was missing.
Yes, and it's not because so math is out of the College of Engineering. So. Because this is currently funded by the College of Engineering, we're not actually banging on their door. I think math would be great. I don't think you should do everything in math this way. I think, so certainly in our department, CS, the discrete math and the algorithms class don't do anything in the CBTF because they're writing proofs. And, we do actually have formal methods people that want to build automatic proof checkers for things like that, for student work. We haven't done that yet. I definitely think that there's a lot of things in math that would be great for the CBTF. I think there's things also where you want to evaluate people's approach to solving problems, which doing some of the stuff on paper. I think some sort of hybrid strategy would be valuable for math. We basically we're not trying to grow, basically we want people to come to us because they see the value of it. So we're not really saying, oh, math, you really should be doing this. If math says we want to do this, we'd be ecstatic to have them involved. But we're not trying to jam this down anybody's throat. So stats is very interested, and they've been, they started with 1 class, now they're doing 2 classes, and I think we're going to see some continued growth from them. And I don't see that being that difference of a story between stats and math. All right, so we've done a bunch of things, student surveys, faculty surveys. This is some data from a faculty survey. We asked them, how did the CBTF reduce your effort to run exams? People are mostly positive. If you say specifically about your reduction in grading load, people are very positive. So what's the difference between these two? Well, I have to still generate the content. And so one of the things that has to be super obvious is it's a lot of work to build the content for the first time. So there's an upfront cost, but once you've done that, it pays dividends forever. So I don't write new exams anymore. I basically rerun the same exams and I tweak them over time. And that's sort of what this is saying, is that question quality is much improved. My TAs and myself can focus on improving questions rather than grading. So there's no longer this giant churn in the exams that we give where you can write a buggy problem and put it in front of students and bad things happen. That we if we find a problem in a problem, we fix it, and then we give the revised problem in future semesters.
Can I ask one more question about that? Which is, what is the barrier in terms of faculty, or what's the technical load on a faculty member or a TA to actually write a question? How technical do you have to be?
It depends what kind of question that you want to ask. So let me show you some of the questions, and then we can talk about what's easy and what's hard.
Yeah.
So assessment's cheaper, and what that does is it frees up staff time to do other things. So one of our key things is that we're not trying to automate things for the sake of automation. We're just saying there's some things that people don't add a lot of value to, so let's stop spending people time doing those things and spend people time doing the things that add a lot of value. So holding more office hours. We've had classes that, large classes that reintroduce lab reports and term projects that they had gotten rid of because of their sizes, but now the TAs aren't grading exams, so they can grade these open-ended things. And we've had faculty go and seek out more active learning pedagogies because, again, we've freed up some of their time to do these things. All right, so that's the sort of broad overview. Let me sort of tell you a little about the student experience. Before I do that, let me just make it clear that I'm not the only one doing this. So this is my colleague, Matt West, who's my main co-conspirator. He's faculty member in mechanical engineering. He's the main author of the Prairie Learn system that I'm going to show you. Dave Musselman is our IT guy. He's amazing and helped do a bunch of the behind-the-scenes stuff operationally. Last year, at the beginning of the fall semester, we hired Carlene. She's our coordinator. She handles basically the operations of the CBTF, hiring proctors, training proctors, dealing with academic integrity issues, dealing with anything when bad stuff happens. Tim Brettle's a faculty in aerospace. Nathan Walters is an undergrad in CS. They've contributed significantly to Prairie Learn, so a bunch of the whizzy things I'm going to show you, they helped make happen. Binglin Chen is a PhD student that works with me. He's done a lot of the analytics work looking at the data that the CBTF generates. One of the neat things about this is when you've digitized all of your assessment, you get all this amazing data you can learn stuff about. And Marianne and Jeffrey are two of the authors of some of the quasi-experimental studies I'm going to show you at the end of the talk. So, are big users of the facility and have studied its educational impact. The other thing I want to point out is we're not the only ones doing this kind of thing. So this is Ron Damara. He's at the University of Central Florida. Around the same time we started, he independently built a thing he calls the Evaluation Proficiency Center. His is built slightly differently than ours. I could explain that after the talk. But it suggests to me that the things that we're doing is not entirely Illinois specific, that it's general enough to be useful at other campuses. This is actually him winning an award, a campus level award for building the EPC at the University of Central Florida. Okay, so what is the flow like? So what happens is around the beginning of the semester, faculty come to us and say, we'd like to use the CBTF and we want to run 7 exams roughly these times. And we do a lot of work to sort of balance the load so that there's sort of a consistent load semester long. And then as the semester runs, then about 2 weeks before the exam window starts, students receive an email with a link that says, go sign up for your exam. And so they go to our web tool called the scheduler, and they say, hey, for your exam, you can take it on Sunday, Monday, or Tuesday, and here's all the times. And oh, by the way, these times are already full, so you can just click on any of these times and make a reservation. They can reschedule as much as they want before the exam happens, and they can actually, with the help of a proctor, if they miss their appointment, they can reschedule again, completely without faculty intervention. So our goal is to, get faculty and their TAs to stop sending emails to students about conflicts and things like that. So the morning of the exam, they get sent another email saying, hey, a reminder, you have an exam at 2 o'clock today, don't forget. The 10 minutes before the exam, so again, we start on the hour, so at whatever 9:50, they can show up to the CBTF, and our exam, we run 50-minute and an hour and 50-minute exams, and so in that 10-minute passing period, we usher out all the old students and usher in the new students. The proctors check photo IDs, we scan them, we assign them seats in the CBTF. I showed you the seats have numbers. We're actually pretty careful. We're running many exams all at the same time in the same space, and so
We try to sit people next to people taking different exams. So even if you look over, it's like, oh, that's mechanical engineering. Oh, well. We have the students store all their stuff on a bunch of racks as they come in. So again, cell phone, leave it in your bag. Don't bring in any paper. You can bring in a pen. And then we give them scratch paper. So some of these exams are for engineering classes where they want to derive equations and do stuff. So they can pick up scratch paper, they log into the computer, they navigate to our website, wait for the go signal. At that point, we generate a unique exam. So again, these questions are parameterized, and in fact, we'll even have multiple different questions in the same pool. So for a given slot on the exam, it's going to roll a die and pick one of those questions, and then roll a bunch of dice to generate the numbers for that question. So every student gets a slightly different exam. Students answer questions and they can grade them interactively. So this is new. So normally when you're taking an exam, you write a bunch of stuff and it's either right or wrong, but you never know. What's neat about grading things interactively is a lot of people then allow the students, if they got it wrong, to answer it again for partial credit. And so you can have whatever partial credit scale that you want, that if you get it right the third time, maybe you get 50% of the points instead of 100% of the points. And then proctors enforce the time limits. They kick the students out when things are done. They say, you have 20 minutes left, you got 10 minutes left. And students at that point can have completely graded the exam, unless there's things that are graded offline, and know their score. Questions about this?
Maybe you'll get to the sort of unit testing of the actual questions themselves, and how do you prove that they're it's not
How
going
do
to
I prove that they're correct? How do we prove that our normal exams are correct? We don't. We test them. I wouldn't say, so in general, my experience has been two things are important. So one is that much like code, if you've got a bug that's going to happen frequently, it happens pretty quickly. So typically when I write a question, I test it a couple times just to make sure it's working, and then usually that means it's working. The second thing I do is a lot of my questions, I put them on homework before I put them on an exam. And so if something's going to blow up, it's going to blow up in homework where it doesn't really matter. And then I fix the bugs before I put it on the exam. The other thing that happens, and I'll show you this in a second, is when students sign up for the exam, they tend to put off taking the exam as long as possible. So the first day, in the first couple hours, not very many students are taking it, and the students that are taking it then are often some of your strongest students. And so they're the most resilient to the bugs, but they will report them because they recognize them as bugs. And so it's not uncommon for somebody to have bugs on their exam, a couple students hit the bug, they fix the bug, and then it's fine for the rest of the students. Is that
fair?
So often if the question was bugged, the students that had it before the question was bugged will just be granted full credit for it. And so if anything, that encourages you to take the exam early, which I think is a fine incentive. Yeah. Fairness is an interesting question that we can have a longer conversation about. But it turns out to be something that faculty seem to be much more concerned about than students, surprisingly. Yep.
Have you thought about asking your TAs to do a trial test of your exam in the week before the actual students can sign up to take the exam?
Yep, that's not an uncommon process and something that we definitely recommend. That's the same thing I do when I write paper exams, is that I want somebody not involved with writing the exam to take the question, show me the answers they wrote, and be like, oh, I didn't think of that answer. So yeah, so that's definitely encouraged and a practice that a lot of people use.
Can I ask? Oh, go ahead.
So are students not allowed to come back and revisit questions? For example, maybe they sort of want to go over their answers.
So again, students can come to office hours usually, and the TA has full access to that, and they can pull up specifically the version of the question the student had and the student's answer, so they can see the student's exam.
But like if on question 3 they're sort of, they think they know the answer but they're unsure, can they sort of set it aside? And
yeah. So they can do the exam in any order, and I'll show you that. So right, so they don't have to do things in a particular order. The other thing is, when they're there, typically when they've used all their chances to get the question correct, or they've finished the exam, it shows them what the correct answer was as we think it is. so they can sort of use that to understand whether the thing was right or not. I'll show you the exam format in a second.
Can you go back? I'm assuming that once you sort of take a look at an exam and you see that like everybody missed a question or something like that, you can assign different point sets to it or sort of make changes at the end to adjust.
Yeah. And I can show you some of the statistics that our tool generates on the question.
Yeah.
So I already went over a bunch of this, but just to point out, security is super important to us. So we're basically asking faculty to completely delegate the running of the most important summative assessments in their class. And if we were just super lax about letting people cheat, nobody would take us seriously. So I already talked about a bunch of things, physical security, proctors checking identity, we control the networking, we randomize the seating. We've discovered a lot of problems where students had mechanisms to cheat electronically, and I think we've plugged all of those now. The main things that we see students trying to do is bring in phones and scratch paper. So we do a couple things. We use colored scratch paper, and every hour we change what color scratch paper we use. So we do that because there's a market for colored scratch paper on our campus now because of the CBTF. We allow students to report other students cheating. One of the things that's true, we have these security cameras. We did a student survey and they said, ask the students, what do you think about having, do you know we have cameras in the CBTF? And there were a bunch of students who were like, no, I didn't know that. And we said, what do you think about that? And we said, overall, the students are very positive about having security cameras in the CBTF. We were worried about a prison environment, but students don't like other students cheating. Most students don't want to cheat, and they don't want an environment where other people can be successful cheating. And so, we have students that report other students cheating, saying, hey, that kid's got a cell phone, that our software lets them report that to the proctors anonymously, and then the proctors can go check it out, and we've got the video cameras. So we run about 50,000 exams per semester. We do somewhere between 10 and 20 academic integrity violations. So we feel like we're catching enough stuff to believe that we're catching a lot of what's going on. I don't think the cheating thing is more widespread than that. We handle most testing accommodations on our campus. Most testing accommodations are either I need extra time or I need a distraction-reduced environment. So the extra time is handled automatically in the scheduler. They just get a longer reservation. The distraction-reduced environment, we've got a few of our workstations where there's partitions that block the peripheral vision. The students can request earplugs if they want. We actually find most of our students that could take their exams at the Dres facility choose to take it at our facility because we're more convenient and we have better hours. They run 8 to 5, we run 10 to 10, and on weekends. So basically all this happens, again, completely without faculty intervention. We do a lot to try to minimize the amount of communication that faculty get, because as a faculty member, you get a lot of emails. We don't need to be sending faculty more emails. So we try to do as much as we can to prevent faculty from getting excess information that's not actionable, but at the same time keeping them informed of anything that they really need to know about. So a lot of things happen, students showing up, they're like, oh, I had an exam earlier today, I forgot, well, the student, we just let them reschedule, that's fine. But if the student feels like they were wronged in some way by the exam, what we don't want them is to go to the faculty member and say, oh, I had this terrible experience in the CBTF, and the faculty member having no way to corroborate that story. And so what we do is we say, hey, if you have a problem with us, you got to tell us, and so we can document it, send that to your faculty member before you leave. If you leave without complaining, you've lost your right to complain. So we produce an incident report, the proctor writes down what they think happens, the student writes down what they think happens, and that gets sent to the faculty member. So at least the faculty member can decide with the information of what to do. Maybe just say, oh, okay, you can have another chance taking the exam or something. So that works pretty well. Cost. Our biggest expense is staffing, the proctors and the coordinator. All told, last year we ran about 100,000 exams. Our expenditures were around 190,000. It comes to just under $2 an exam. That includes scheduling, proctoring, grading, paper, whatnot. So that's pretty good. That some of our departments just the printing cost of exams alone, was in the $1 range. So we're pretty close to that. And if you compare this to something like Proctored, which is like $25 an exam, we're an order of magnitude cheaper, and I believe significantly more secure, but we don't have data on that quite yet. Working on that. Okay, so what do exams look like? So this is the exam format, at least in the PurryLearn tool. So there's a bunch of questions. You can go visit them in any order. In this case, each question was worth 10 points, and that if you didn't get it right the first time, you got it right the second time, it's 9 points, then 7, then 5, then 2, then 1. So you go into the question and you can save your answer. You don't have to grade it immediately. You could grade them all in bulk, or you can grade them one at a time. Typically, students will basically work on one problem until they're done and then move on to the next problem. So does that answer questions about the exam format? The other thing I want to show you is the actual tools, the question. So just as a glance, so this is our scheduler tool. This is the list of classes that we're running this semester. So there's a bunch of them. Sadly, my resolution's not being pretty good, but this middle column, registrations, is the number of students that were at some point signed up for the class and visited the scheduler. So you can see that most of these things are in the hundreds of students, just to get a sense of how many students that we're interacting with. So
are you pulling data directly from your student information system? So
yeah.
You're updating. Okay.
Yeah.
So you're okay. Yeah.
Yep. So we get that. So we also allow provisional registrations, because I don't know if you have this on your campus, but sometimes our classes are full and students, are on a wait list for the first couple weeks, and so we have a way that they can get in, but then we can kick them out after week 3 or whatever the faculty decides. Okay, so this is PurryLearn. This is the LMS that we wrote. Again, the key thing about PurryLearn is you can write a piece of code that generates the question, and you can do anything in HTML5 that you want to. So I teach computer architecture, so hardware stuff. So what this question is doing is it's showing the students a circuit and asking them to fill out a truth table, if you know what that means. If you don't, that's fine. The key thing is that this is a problem generator. So it generated this circuit programmatically. And so if you look at the circuit, there's 2 NOT gates on the top. That's enough to sort of, I have the student view on, so I have to actually answer the question. In homework mode, if the student answers the question and gets it wrong, I say grade it, and it says, oh, you got it wrong. But then it says try another question. So I go back. Oh, it gave me 2 NOT gates at the top. Darn. Let's go to the instructor view. Oh, so there's a different version of a question. And so these aren't JPEGs being stored somewhere. I'm generating an expression and converting that expression into a picture. And then asking the student to do that. We've done the same thing in mechanical engineering. This is a problem where there's a beam with a bunch of loads, and you can see there's a down load, then this red, then a blue up. If I generate a new variant of this question, it'll actually put the forces in different places, and it'll also change the numbers. So there were some questions about how much effort it is to write questions. So there's a couple things that are really easy. One of the things that's really easy is to write a question where I basically give you one picture. I draw a picture, a static picture. I write a bunch of HTML. This is actually a template. And I put spaces, for these numbers. I write a little simple Python program that generates random numbers within a desired range. I write an equation that takes those random numbers and computes the right answer. And I'm done. That basically the system will say, within a certain tolerance, compare the student answer to the correct answer. So that kind of question you can write in about a half an hour. If you have a pencil, if you have a textbook question that you want to convert, that you can do in about a half an hour. The other thing that turns out to be remarkably easy is programming questions. This is an example programming question from our CS1. It's not important to read it, but basically, given this binary tree, you write your own binary tree class that inherits from that has a certain property. So because this is our CS1 class, we have them write the code directly in a browser, so not burdening them with the IDE. And they use this for homework day 1, and so it's pretty straightforward. The way these things are graded is actually very general. That the Prairie Learn has what's called external autograder functionality, where the person that wrote this question picked a Docker container that had the software installed necessary to grade that question. And when the student submits the answer, they take that student submission plus whatever test files and scripts that you want, creates a Docker container, puts all that stuff on it and pokes it, and it generates a piece of JSON that it hands back, which gets turned into something that looks like this, that says, oh, you got 0 out of 100 points for this thing, and here's some feedback on that. So basically, it's a series of these tuples that are, you got X out of Y points, and here's some message. And so people have taken this, and I've personally written autograders for Verilog and MIPS and C++. I sold the C++ one. I wrote a Java one. Somebody else wrote a different Java one because they didn't like mine. Wrote a Python one, OCaml one, Haskell one. So it's pretty straightforward. It's basically the same kind of thing that you do for auto grading homework you can do in this context. And so once you have that auto grading setup done, then writing a new coding question, typically you can do between a half hour and an hour. You need to write the code, you need to write the gold answer in order to test your test cases are correct, and then test it out a couple times.
So this was my question when you mentioned chemistry and some of the others. Have you run into yet an issue where the faculty or the discipline does not have the skill set to actually write the question? Do you know what I mean?
Yes. So typically, if this faculty has no interest in doing this, they don't come to us. So the chemist they had a bunch of stuff in Lon Kappa that I helped them port. I wrote a tool that basically took their dump from Lon Kappa and made sort of crappy versions of questions with their Perl code commented out, because I didn't want to write a Perl to Python translator. I didn't want to have anything to do with Perl. But they knew enough, that I think a lot of, faculty that are interested in this can code at the extent of, like, I can declare variables, I can generate random numbers, and I can write simple equations, which gets you a remarkable way to doing, a lot of numeric questions. So that the chemist that I know is doing exactly that. The crazier stuff takes a lot more effort. So this is a question where I'm asking them to design a finite state machine. And so this tool is a little CAD tool for designing finite state machines. I can label the edges, I can, whatever, I can label the outputs of the nodes, and that then I can run a bunch of test vectors against this and compare the output versus what a gold standard answer did and grade their question. Here's a question where the students are given a structure, with a force on it, and they're asked to draw a free body diagram. And so, you click and drag this stuff. You say, oh, there's a force here, and there's another, force over here, blah, blah, blah. This is the kind of stuff that I'm showing you because I want to say it's sufficiently expressive to do whatever you want, but it takes a lot more effort to build one of these things. But sort of once you've built it, it's very easy to do proliferations of this kind of idea, to do similar things. This is an example. This is my friend, the roboticist. He has a little robot in 3D. And he's saying, okay, here's a translation and a rotation matrix. I want you to understand physically what these things mean. So take this robot and it's hard to see on the screen, but move it and rotate it into the position that corresponds to those that translation and rotation matrix. This is something that a student worked with me. We wanted to teach them command line skills. So we have a question that connects to a Docker container on AWS that basically, oops, I need to restart it because apparently, I have interaction with a real terminal. I can do whatever I want. So I can say ls, who am I? And inside, I'm asking the students to do a task. To say, hey, there's a file called this. I want you to rename it to do that. And if I initially grade it, it says, hey, you haven't done the thing that you were supposed to do. If you then do that, these random names, then I say grade. It gives me a secret that I can then copy and say the thing can validate that I did this. And then I have a question where the students fill out a pipeline diagram. so on and so forth. So we have tools to generate automatic trees randomly. So it gives you a sense of the scope of the things that we can do. But I think the key thing is that you don't have to do the whizzy stuff on day one. You can do all the easy stuff, and then once that's working, you can add in more and more whizzy stuff as you sort of try to cover more and more of the learning objectives of your class. Okay, so let me tell you a little about the science of things. So one of our main objectives, people are like, oh, I don't want to dumb down my exam. The next main objective that people have is they're like, oh, asynchronous exams, aren't students gonna cheat? That the standard thing that the concern is that if there's an exam period, you have one student that goes and takes the exam, and then they can tell another student what was on their exam, and they can study and then take the exam. And so we refer to this as collaborative cheating, and the key thing that we do to address this is randomizing the exams. The first thing to talk about is how do the students behave when we say, hey, you can take the exam at any time. What we see is a couple of things. One is that students are highly biased to take it as late as possible. That we see students prefer the last day, and they typically prefer the last hour of the last day. The number of reservations grows till we are at full capacity at the end of the day. So that's one thing. So students prefer the last slots on the last day. Also, scores go down over time. And at first, people think this is really weird until I tell you. You're shaking your head, but if you're confident about the exam, you take it whenever you want, whenever's convenient. If you're scared of the exam, what do? You put it off as long as possible. And so that explains this behavior. And so we've looked at a huge number of classes and a huge number of exams, and this is remarkably consistent behavior. So across all these exams, we see that scores go down by roughly 4/10 of a standard deviation throughout the exam period. So largely, we've done some analysis that say this is largely just the weaker students are choosing to take it later in the week. So it's not like you could have an intervention where it's like, oh, well, if we force these students to take it early in the exam period, they'll do better. No, it's just them, demonstrating their insecurity.
Greg, do you ever have a situation where enough of them delay it that they actually can't find enough time slots to get in?
Yeah.
Well, if the time slots fill up, then they have to take it earlier.
I see.
So do you right, so midnight, boom, everybody gets the email. Do you do anything to sort of randomize the ability to sign up for a time slot? Or have you had
So the thing that we do is we stagger the last days of the exam so we have a model. We've seen this enough that we have a model of student behavior, and so in the beginning of the semester, when everybody comes to us and says, oh, we want to run 7 exams at these days, we run the model and we look at the load and we say, okay, these days are over capacity, and we nudge people, left or right so that we're never over projected capacity. And by doing that, it hasn't been a problem. But we're very careful not to have 3 big classes ending on the same day, especially
I could see complaints.
No, so we in general don't see complaints. And so the other thing is we run at about 70% capacity. That's sort of our, that a lot of people don't want to take 10 a.m. exams, and we understand that. Some people do because it's quieter, actually, but so we typically don't see problems. So the second experiment, so this is interesting, and it suggests that if there is collaborative cheating going on, the effect is at least not as strong as this other effect, but it doesn't actually say that there's no collaborative cheating going on. So the second thing we did is an experiment where we built an exam in this way. So all the exams semester long in Matt's class, they did this. So they basically had 3 problems that were never exposed to students through homework, and then 3 problems that were on the homework but also on the exam. And this is sort of encouraging the students to go back, review the homework, make sure you can do all that stuff. And what we did is that in this slot of the exam, there was 1 question. Everybody got the same question. In this slot in the exam, there were 2 questions. You got 1 of the 2. In this slot of the exam, they got 1 of 4 questions. And what we could do is, because these questions were on the homework system, so maybe student A would get those questions and student B would get those questions, In the homework system, we could go back and look to see which problems the student studied. And if a student didn't have information about what was on the exam, in general what they would do is they'd sort of study everything kind of equally. And if a student had strong information about what was on the exam, their profile would look like this, that almost all of their studying would be on questions that were on the exam. And so what this let us do is say, to classify the students into non-cheaters and cheaters. And I'm calling them cheaters, but that's really in quotes because they're just being rational, optimizers, right? They're getting as much information as they can. What we want to do is build a system that's tolerant, that they're not actually getting an advantage, that doesn't encourage that behavior. So what we did is we looked at their performance of these two groups of people on the questions that weren't on the homework system versus the questions on the homework system as a function of pool size. And what we see is the cheaters do slightly worse in general on the hidden problems, and they do much better on the problems that everybody gets the same problem, but by the time we get to a pool size 4, that their advantage has basically disappeared. You can look at this and say, well, they do about the same here too. We think there's a bit of a ceiling effect, that just by chance the problems in this bucket happen to be easier, and so the advantage you could get by cheating is capped by, if non-cheaters are getting them perfect, then the cheaters can't get a huge advantage. So the takeaway is that we think somewhere between 2 and 4 different problems plus randomizing the parameters is enough to sort of, make the information of gathering all the different instances and knowing what's on the exam harder, and then just storing all that stuff in my head. That if I can memorize the solution to, whatever 23 problems, that's probably a harder task than just learning how to do the material, which at that point, I'm fine. If they really desperately want to cheat, I'm not going to try to stop them. All right. I'm basically out of time. I just have a couple more slides. I want to show you some experimental data on the improvement of learning stuff. So frequent testing, faculty in general really like this. So one faculty member was saying that students are staying on top and being more involved in discussions ever since I started doing more frequent testing, which makes sense, right? The students had to learn the stuff, they couldn't put it off, so that's great. So we have 2 quasi-experimental studies that were done. Faculty that the semester before they joined the CBTF, they had a final exam. We looked at the results, and then they adopted the CBTF. They made changes to their class, but the only changes they made were related to the CBTF. They didn't. So it's the same instructor. It says different semesters, but it was the same. It was fall against fall or spring against spring, and they basically just shifted some of the assessment activities to the CBTF. So either it made the assessment more frequent or more reliable, and I'll explain what that means in a second. And what we're doing is we're comparing the scores on an unchanged pencil and paper final exam. So the final is on pencil and paper still, so there's no mode effect from having practiced a computer-based exam. It's basically the same exam. And this is a better estimate of learning, I think, than the overall grade, because lots of stuff gets bundled into the overall grade. All right. So 2 experiments. So the first one was in our solid mechanics class. The faculty member replaced 2 pencil and paper midterms with 5 quizzes and 5 second chance quizzes. And so the blue shows the grade distribution they got on the final. Without the CBTF, and then red is with. So you can see there's a huge reduction in the numbers of D's and F's on the final exam, and a corresponding increase in the number of A's. Pretty good. I like that. The second class that did a study was our programming languages class in CS. They took 2 midterms, and instead of doing them pencil and paper, they converted them into computer. So they still only had 2 midterm exams, but then the second thing they did is instead of having the students submit some of their programming assignments just electronically, they said, okay, here's the programming assignment, go and do it, and when you're done, don't send us anything, just go to the CBTF, we're going to ask you to rewrite a random 20% of that assignment, in a proctored space. So they did that for 4 of the machine problems. And what they saw was, again, a large reduction in the number of D's and F's on the exam. It didn't end up changing the number of A's, but basically those students showed up getting B's and C's instead. So I think these things of frequent testing, second chance testing, really is good at addressing the tail of the distribution. The last thing I want to show you is about second chance testing. And I'm actually going to show you data from second chance testing that I did on pencil and paper from before this, because a bunch of things are funny about the post-CBTF. But the key thing, again, is some students have difficulty with understanding expectations and understanding their level of preparation. And so this is, my class is actually fall 2012. And what's shown in yellow in this pinky color is the distribution if I only look at the first chance exams. And then the blue and purple is the exam distribution only when I include the second chance exams. And so what you can see is that a bunch of the motion is from these lower parts up to the higher parts. So it goes up to 65 because in my class, 65% of the grade is determined by exams. And so the mean goes from 50 up to 54. So on average, the students are doing better. But arguably more important is the standard deviation is shrinking. The distribution is tightening, that we're having fewer people that are going to fail the class. So that's it. So CBTF is now a fixture in our College of Engineering. We expanded to our second room. I think everybody involved pretty much agrees that it makes testing more efficient and more effective in their classes. We're mature operationally. I think we're pretty secure, and we're running at production scale. It's well liked by faculty. We do not do a lot of effort to twist people's arm to use it. We send out emails every semester saying, anybody interested in using the CBTF, come to us. It does involve a significant upfront investment. You have to do a lot of work to convert your stuff. Often people have stuff in a format that, at least, you can convert some of it pseudo-automatically. But I don't want to say like, oh, this is easy, no problem. It does cost an upfront investment, but it pays huge dividends semester after semester. So basically I'm here to say, hey, we did this thing. I'm happy to share our experience and help you guys consider adopting a CBTF. So, yep.
Have you given thought to that format itself and how adaptable it is to other platforms and other things?
So we actually have two LMSs, two custom LMSs that are currently running in our CBTF. So there's another tool that another faculty member wrote called Relate, which is used in a number of our numerical methods classes and our Intro to Programming for Engineers class. So we're not learn specific. We just find that a lot of the commercial tools aren't well set up for doing this, and so people, rather than fight those tools, find it easier to port their stuff to our tools that are more expressive anyway. Ron uses Canvas. I don't know what if you guys are Canvas campus. He uses Canvas down at UC Florida, University of Central Florida. It's a UC school, he does largely multiple choice questions and then does what he calls score clarification. So it's a practice that we're starting to prototype at our institution, which is we scan the scratch paper and students after the exam can review the answers in their scratch paper and make a case for why they deserve partial credit on things. And this is really interesting because instead of having TAs look at the scratch paper and try to make sense of it, you're making the student do the mental work of understanding what they didn't get right and making a case for what they did, covering part of that. And so he finds it's fabulous in he says, students come to my office hours more prepared than they ever have. They don't come and say why did I lose points on this? They come in and say, okay, here's why I deserve points on this thing and this other thing. So it's done in the context of a secure room where the students can come in, they can get access to their scratch paper and their exams, and the TA is there to do the first pass of dealing with the score clarification. The other thing he likes about it is it makes him the good cop, that the computer's the bad cop. The computer takes away the points, and then he gets to give back some of the points. So we're not PrairieLearn, we're very PrairieLearn agnostic. I think if you had internal tools, so So yesterday I was down at UC Riverside where Frank Vahid, who is one of the people involved with Zybooks, is, and so they basically have an electronic format for doing a bunch of things. I think we have some lessons that we would communicate to you about, like, okay, here's some things to be aware of if you do this, but I think the idea of a computer-based testing facility is more broad than Prairie Learn. Does that answer your question?
Yep.
That's great.
So I have three brief questions. One, can I easily customize my exam for that semester? Let's say we have a bad air day and we end up losing some lectures and I have to drop some, or
Yeah.
snow day.
Yeah.
Is it easier for me to go, oh, the exam's coming up, let me just drop the stuff that I don't get to cover this semester? Easy to do from a metadata point of view, I can just
Yeah, so basically
do some things.
the Prairie Learn has the notion of questions, so they basically have a giant directory of questions, and every assessment just basically refers to the assessment that you want on it. And so the 5 minutes before the exam starts, you could change what was on the exam. You shouldn't probably change it during the exam, but if a question's broken, people might do that. But yeah, so it's very flexible. Basically, that the content for a class is maintained in a Git repository, and there's a button on Prairie Learn that you poke it, says pull down this new thing, and it checks it and makes sure that it's consistent, and then boom, from that point on, the exam is what you said it is. So it's just configured in a JSON file. Some people say JSON's ugly. I think it's cute.
So the second question I had is, could you use your system outside the CBTF where students could log in and do homeworks or lab problems?
Yep.
And you've already built this whole infrastructure that
Yeah.
has these questions. Why not have them practice and play with it in a way that's not an assessment, kind of a formative assessment rather than a summative assessment, but they're just playing with it. If they get it right or wrong, it's only for them, but it doesn't actually count towards anything.
So that's exactly what I'm doing here. So this is live. That so in my class, is this my class? This is what my class looks like. So we do it for homework, but it's very intended to be formative in that you need to earn a certain number of points doing this kind of question. But you can have as many attempts doing that kind of question
Right. Exactly.
to get that number of points. And if it's actually that you get the streaking bonus of, like, if you got it right last time, if you get it right the second time, it's worth more. If you get it wrong, it resets back to the lower level. So if you already know this stuff, you can bang out a couple instances really quick. If you don't know this stuff, you're getting it right 1 every 5 attempts. You have to get it right more times in order to get all of the points. But yeah, so we're definitely strongly, there's a bunch of faculty that want, I'm not going to say they're wrong, but want to use homework as a summative assessment where your score on the homework is important to your grade. And a lot of, our mindset is very much the homework is to learn to do the stuff that, you're grading on effort, in that I want everybody to get to 100. Some students do this quickly, some students will take longer, but it's not important to us. We scale the weights in our grading things, assuming that most students are going to get almost all of the homework points, at least in this kind of homework.
And the last question I had was, so much effort is required to create the assessments. Does that mean that instructors don't want to change their course as they move from MIPS to RISC or something like this, when you change some part of the system? Because, oh my gosh, I've already spent 2 years writing all these questions that may not translate. They might, but they may not translate. And so I don't want to refactor my course because of the motivation and all the
I think so. It probably does somewhat, but like we already, I think that's true already. And you have to change the slides, you have to change the homework, you have to, not only you have to write new exams, but you have to write practice exams so the students know kind of what, so there's already a relatively large disincentive. I think it hasn't, it in general doesn't, because most people don't, like that change you're talking about is uncommon, where you change one detail which has impact across the class. That most people, every semester, they improve one topic of the class. And, I think this actually facilitates that, because, you're not spending as much time doing, writing assessments for the other part, that you can say, okay, this semester I'm going to improve this part of the class, and that's where I'm going to direct my energy. So that would be an interesting question to study in more detail, but my gut is it may provide some disincentive for completely changing the class. That said, our programming language class in the fall is taught in OCaml, in the spring is taught in Haskell because different faculty teach it, and they each have independently developed stuff for this. And so, I think the people that care enough about education to do this don't let things like that get in the way of doing what they think is right. You had a question, Matt?
Well, I had several. One, the homework, like the slide you have up there now, they do not have to go to the testing center to do the homework. That's
True.
just laptop at home
Right.
or
Yep.
cafe.
Whatever. Yep.
Okay.
Right. So
And
we
then-
can configure things to be in the testing center or be open.
Okay. And then just a question of curiosity, because so I really like this approach. And one of the things I like about it, ancillary benefit, would actually give me back lectures, right? Because exams would no longer be taken in class. Is that what is done at UIUC? Or on the week of exams, do you
Is this still being
not
recorded?
hold class?
So
Because clearly you don't throw something during unofficial.
you say that, but I've actually had a programming contest that we did
Okay.
we ran during unofficial unknowingly because I was dumb professor. But
I used to teach there.
okay.
So that's
So unofficial is unofficial St. Patrick's Day, which is the day that students start drinking at 8 a.m. in the morning and often don't go to class. Normally, that's more of a South Campus phenomenon than in the engineering campus. I typically still cancel some lectures, or I make them optional. And then the students joke, it's like all lectures in CS are optional,
Right.
But so some people interpret that very strictly, and other people interpret it more loosely.
Okay.
But it certainly gives you more flexibility. But I think if you looked at the letter of the law, if you're expecting students to do stuff outside of lecture where it's like they have to be there, you should cancel some corresponding amount. There's this whole argument of how much you should cancel, and so I typically, I give them 50 minutes for the exam, but most students finish in 20 minutes, so I count it as like, oh, that means I should cancel 20 minutes of lecture time and not 50 minutes of lecture time. So I run, I have one optional lecture where, so I teach the architecture class, and basically the class goes up to the state of the art of 1985, and I have one lecture that covers from 1985 to the present at just like super speed, which is just, most of the bunch of students come because it's sort of interesting, but it's like, none of that is tested, and so, but. Yep.
So I'm kind of curious about what kind of work you see from students on the scratch paper. I teach a very mathematical class, and one of the things I've observed is that students are really, really hesitant to write something wrong down on paper, and often there's a trend now of they taking their homework, and so they want to do every calculation in their head and type the right equation into their computer instantly. And I keep telling them you're not going to learn.
Right.
Try to do
The
everything-
scratch paper is for
the scratch paper is there for
doing things that may not work,
for
right?
a
Yeah.
reason. And so I'm really curious if having this kind of interactivity with the computer will you observe that it pushes them more in that direction where they're even more hesitant. They're saying they're hesitant to write a wrong equation on a paper.
Right. Well,
no one's gonna see
so right now the scratch paper is being immediately thrown away, so there's no incentive not to write anything on it. So we've definitely seen the scratch paper phenomenon be specific to the non-computing classes that so mechanical engineering and whatnot. That those are the classes that are looking at actually scanning the scratch paper and looking at it. I think if on a test where anything you say may be used against you, maybe that's what they're afraid of. If you instead flip it so that you say, hey, anything you write down, you could conceivably make a case for getting points back. Definitely, Ron, however, has seen the phenomena where the students will write multiple possible solutions and try to come to them and say, oh, here's the work that shows that I was really close to the solution, and you flip it over, and it's like here's the solving the same problem in an entirely different way, that actually leads to the answer that they were was the one that they bubbled in, So he has a name for it. I forgot what it is, but they're going back to that's not important. So we haven't. I certainly haven't looked at their scratch paper. I don't think anybody's looked at their scratch paper closely up at our institution. But I think right now, in practice, they feel very comfortable to write all sorts of stuff on it. I'm not sure.
Yeah,
Well, it would certainly be an encouragement for them to write on the scratch paper. If
Right.
it was going to be scanned and they could get potential points back.
Right. But I think, right now, they actually, the uses of scratch paper is pretty significant. That, like, we specifically say, don't take a huge stack right away. Take, 1 or 2 sheets to begin with, and if you need more, come and pick up more. Just because, what we don't want is, standard, you guys live in California, right? It's like people take a big wad of napkins, use one of them, and throw them all away. We're trying to not destroy too many trees. But there are students that'll go through 5 or 6 pages of scratch paper in a 50-minute or 1 hour and 50-minute exam. So, yep.
That's a question from Jen. She had to leave.
Yep.
She texted me. One was if you have anything to say about accessibility for the platform in terms of people with disabilities.
For Prairie Learn, we don't have a lot. We do have 1 wheelchair accessible seat. Because we are a super flat campus, we are particularly wheelchair accessible. So we have 1 seat where the desk rises up so that.
More like hearing or vision. And stuff.
Yeah, so most of the exams don't require hearing per se. The
Vision is hard.
vision would be hard. I don't like. So my experience is that we've dealt with. On the order of 98% of the kind of accommodations that we've seen in the classes that have chosen to use the facility. So engineering might see slightly different population of students than campus as a whole. The most challenging, for me personally, the most challenging accommodations that I've needed are students that can spontaneously miss deadlines, where it's just like, okay, I'm having a bad week, you need to re-offer all this stuff to me in a different time, and there's a number of mechanisms that we have to address that. Vision hasn't been. I want to say there's 1 case where there may have been an issue, and certainly we do still have the DRES, the disability something. Part of campus that can handle super severe things like that. The other thing that I know that we've had issues trying to deal with is students that have like severe panic attacks, severe anxiety, and again, it's not, so one of the things that's true is that the CBTF doesn't say, we're going to handle all of your issues, Mr. Faculty Person. That if you have a student that has something that we can't support any more efficiently than you can, we typically turn it back to the faculty member and say, okay, you either need to just print out the exam in super large font and let them do it on paper, or figure out how to do it for yourself. But we feel pretty good about covering enough of the things so when something really intense comes along that that's without us, the faculty member would have to deal with that, or the DRES center would. So we rely on falling back on that.
She had 2 more questions, and I can back into 1. One was, and I think it's an extension of what I was asking before about the LMS. Is there any thought to LTI compliance? Allow you to plug into some
so Prairie Learn outputs LTI. So we've had a bunch of our Coursera classes interested, because Coursera has been so slow at providing the features that our faculty want. Some of them have started developing, even though they're not using the CBTF, so the number of classes that are using Prairie Learn is actually significantly larger than the number of classes that are using the CBTF. And one of the reasons is people working towards doing their content. So I don't know, I think this semester is the first semester that they're actually looking at plugging it in and going production. But I'm not involved with that, but there's definitely people that are involved with having PerryLearn accept LTI connections.
Okay, and then the other last one was, I know she had an analytics person. Are
Yep.
there any plugins or thoughts or process to get the data in the hands of the student success tools or the advising applications?
Yeah, so we've thought about that, but we haven't done it yet. So I think that's super interesting, and it's something that we keep talking about. But that's it's kind of a different set of people, and so kind of we're like busy enough just getting this thing working that we haven't done that. But I think it's a fabulous thing and something that I would like to see our campus do, because I think one of the key things is bringing together the information that multiple distinct people have. It's like, oh, student X is not only skipping my lecture, but he's skipping all these other classes and not doing stuff. And that's where you're like, okay, this is a red flag. Where, if a student misses my class a couple times, I don't necessarily freak out. Yeah.
What is an overview of the timeline? Say, like, if a faculty member came to you and was like, I'm interested in adopting this, like, what are some of the things that you tell them, or like, is it possible to roll it out like a prototype in a semester for them, et cetera, et
Does
cetera?
it require sabbatical to put together?
Yeah.
So one of the things we encourage is to spend one semester just using PerryLearn for homework if you're going to ultimately use PerryLearn. Build content for and run it in homework and make sure that it's working. Make sure you have enough stuff, because what you don't want to do is like have scheduled your exam for whatever September 26th, and then there's no actual content for your exam. One of the things that we've so some departments have given faculty members like some summer salary in order to develop or support a TA to do development. We see, if I go back to the slide of our adoption rate, you can perhaps see that we have higher adoption in the fall of new people than in the spring. That we sort of have this big jump from spring to fall, and then a little jump from fall to spring, then a big jump from spring to fall, and that is basically a bunch of people spending some of their time over the summer to develop content in order to go in the CBTF. We definitely, I think it depends a lot, what your goals are. That we've definitely had classes, so a bunch of our physics classes are using us only for second chance exams, so they run Scantron exams for their first chance exams, synchronous, and then they weren't running second chance exams before, so they're like, how could this be worse than what we're doing now? So there's a number of ways that you can sort of sneak into it and not have to. The thing is, you can't expect people to build all of the content and then start it. That if you want to convert one or two, take some of your midterms and convert it into quizzes that you can give, and that just means there's less stuff on those. Still give those midterms, but they're smaller and there's less stuff for you to manually grade. You can do it incrementally. But definitely if you can do one semester of, hey, I have a bunch of stuff that we do as homework, and then I can just take that homework stuff and do it in the CBTF. It's good. The other thing that we recommend is doing some sort of exam zero, especially if you're in a discipline where the students won't have been in the CBTF before, where the students come in, they sit down, they're in that environment, they're doing the kinds of things that they may end up doing on your exams, but it's not worth very much. It's worth enough to make them do it, but it's not worth enough that if they do badly on it, it's going to hurt their grades. Maybe like 1% of their final grade, in week, a week or two before your first, actual assessment. And that way, you just want the students comfortable taking the exam. The other thing I would recommend is putting out a practice exam, in PerryLearn or whatever tool you're using that has a lot of the same shapes of things, activities that they'll have on the exam. That you don't want students coming in and being surprised by the exam. Yeah?
So I'm kind of curious, since the exams are being abstracted away from the instructors and from the TAs, is there any sort of like thing that you provide to instructors, such as like grading distributions and like flags for
specific students in their class that may be potential cheaters? Like any flags for the instructors to know this information such that they can deal with the student directly, or also just understand how their class is performing in relation to other classes, or
Yeah. So I guess I don't completely agree with it sounds like we're taking the class away from the instructor. So the instructor is the one who's deciding what's on the exam still. We're just the CBTF is just a room that we make sure your students show up and them and do whatnot. So there's a lot of stuff built into PurdyLearn, for example, that just gives you feedback on how things are doing. So again, these are the homeworks, and it's showing the distribution of student scores on the homeworks. Here's the exams. So that's a test of spatial ability, so it's not actually summative. But so for example, this exam, we can look at the individual, oops, I clicked on the wrong menu item, question statistics. So you can get a lot of feedback about the specific questions. So for example, here are 4 questions that are all put in the same slot in the exam, and you can see that students are behaving pretty similarly to them. If I go down here, where was it? Right around here, I have 2 questions. This is a different slot again. They're behaving pretty similarly on these. You wouldn't want to put this question in the same slot as this question because it would be unfair to the students. But you can get feedback on, are the students behaving roughly similar no matter which version of the question they get. So this is standard mean score and discrimination. You can see the quintile performance. We plot that on this plot. More numbers than you could possibly deal with. So you can see that. There's also, I won't put it up for FERPA reasons, but you get a list of the students and how they scored. You can go into the individual student's exam and look to see what they did. I don't know what's this. Oh, this is overall student population. This is here's a violin plot of day 1, day 2, day 3 of the exam. Again, you can see that more students take it there, and the exam score goes down, largely because the students that aren't doing well have chosen to take it on the last day. And this is all generated interactively, so what's actually fun is to watch on the last day as the scores drop as the day goes on, because, again, the weaker students take it later in the day in general. So we basically built in, whatever analytics that we could think of. So here's details on duration. So you can see a lot of the students are taking, some amount of time, and then there's some laggards that are basically at some point they just are time limited and they have to leave. So we're trying to get back. So one thing that's true is that it's possible to become disconnected from how your students are performing, and so one does have to be proactive in, so like when I teach, one of the things that I do when I teach in a large lecture class, I also teach one of the discussion sections because that helps me keep the pulse of the class. From standing up at the podium and the students are scared and never talk to me, it's hard to know, are they getting things or not. And I think you have to do a similar thing here of just reviewing the statistics and maybe looking into some of the students that aren't doing well, why aren't they doing well? So this, if there's a side effect, this could make it easier for you to not do those things. Those are awesome questions.
Well, let's thank our speaker for coming in. Thank you very much.